Let us understand addition of vectors. Let's say this is the vector A bar. This is another vector B bar. The process of adding two or more than two vectors is called addition of vectors. The first vector is A bar plus second vector is B bar. The result is also a vector called as resultant vector, which is denoted by R bar. This is an object. The vector A bar having 10 newtons force applying on this object. Another vector B bar having 10 newtons acting over same object in same direction. In this scenario, the resultant force on the object is R bar equals to A bar plus B bar. Here A bar equals to 10 Newton and B bar equals to 10 Newton, which is 20 Newton. If B bar is exactly opposite direction to A bar, then what is the resultant? Let's say vector B bar is positive with reference to vector B bar's direction. The vector A bar direction is negative. Therefore, the resultant R bar equals to A bar plus B bar, which equals to minus 10 Newton plus 10 Newton equals to 0 Newton. Vector addition is not just algebraic addition, because we have to consider its direction also. There are three laws for addition of vectors. First law, triangle law of vectors. Second law, parallelogram law of vectors. And third law, Polygon Law of Vectors. Let's understand about Triangle Law of Vectors. This is a vector A bar, and this is another vector B bar. Both vectors are non-zero vectors. Now move the vector B bar such that tail of B bar coincides with head of A bar. Now, A bar and B bar in same direction. Draw another vector from tail of A bar to head of B bar. Observe a triangle is formed. Here, A bar is this side of triangle and B bar is this side of triangle. Now, this side of triangle represents resultant vector R bar. This vector gives addition of vectors A bar and B bar. On conclusion, triangle law of vectors states that if two non-zero vectors represents two sides of a triangle taken in same direction, then the third side of the triangle will represent the resultant vector taken in opposite direction. Now, let's understand about parallelogram law of vectors. This is a vector A bar, and this is another vector B bar. Both vectors are non-zero vectors. Now, move the vector B bar such that tails of A bar and B bar coincide. From head of vector B bar, draw a line which is parallel to A bar. Again, from head of vector A bar, draw another line which is parallel to B bar. Observe, a parallelogram is formed. Here, A bar and B bar are adjacent sides. Now, draw a diagonal through common tails. This diagonal represents the resultant vector A bar, where A bar is addition of A bar and B bar. The magnitude of A bar is given as square root of A square plus B square plus 2AB cos eta, where eta is angle between A bar and B bar. Angle between A bar and A bar is alpha, and angle between B bar and A bar is beta. With alpha and beta angles, we can say the direction of A bar, where angle alpha and beta calculated by following equation. Tan alpha equals to B sin theta by A plus B cos theta. Tan beta equals to A sin theta by B plus A cos theta. On conclusion, parallelogram law of vectors states that if two non-zero vectors are represented by the two sides of a parallelogram, then the resultant vector is given by the diagonal of the parallelogram passing through the point of intersection of the two vectors. Let's understand about Polygon Law of Vectors. Let A bar, B bar, C bar and D bar are four vectors. Polygon Law of Vector is used for adding more than two vectors. Move B bar such that tail of B bar coincides with head of A bar. Now move C bar such that tail of C bar coincides with head of B bar. And also move D bar such that tail of D bar coincides with head of C bar. Observe, we have a unfinished polygon with A bar with this side, B bar with this side, C bar with this side and D bar with this side. Now, draw a vector from tail of A bar to head of D bar. This vector is the resultant vector A bar, where A bar is addition of A bar, B bar, C bar and D bar. If a number of vectors can be represented both in magnitude and direction by the sides of an open convex polygon taken in the same direction, then the resultant is represented completely in magnitude and direction by the closing side of the polygon taken in the opposite direction.